These are the notes for Algebra 2, Section 4.10. They have to deal with writing quadratic functions and creating quadratic models. Now, a best-fitting quadratic model is the quadratic equation that matches given data most closely. Now, typically, if you were going to do this, we would take data points that gathered from an experiment, and we would use the calculator to find a regression equation that matches the data. What we're mostly going to concern ourselves with here is taking information either from a graph that we are given or that was just given to us and using that information to write an equation, a quadratic equation, that models that information. Now, you can use different forms of quadratic equations to find a quadratic model, and it depends on what information you're given. Right? We have three different forms of quadratic equations. Right? We have the standard form, which is ax squared plus bx plus c. Right? That's our standard form. We have our vertex form, we've seen this before, is a times x minus h squared plus k, where h and k, hk is the point of the vertex. And we have our intercept form, which you should remember is a times x minus p times x minus q, where p and q are both x-intercepts. So these are our three forms, and depending on what information we're given, we will pick one of these three forms to work with. Now, the ones that we're going to concern ourselves in this video are vertex and intercept forms. Those are the two that we're going to be looking at and how we could get the information using those forms. So we look at example 1. Now, example 1 gives us this picture. Now, it's important that we look at the graph that we're given or look at the information we're provided to decide which form of a quadratic equation we want to use. So, for instance, in this particular equation, we are told that the vertex is at the point -2, -3, and we are told that it also has a point 0, 5. So we're given 2 points on this quadratic, this graph, this parabola, and one of them is the vertex. Since we have a point and we have the vertex, we want to use vertex form, and that vertex form is y equals a times x minus h squared plus k. Now, we should remember, of course, that when we're putting, that when we have an equation that we're graphing, h always changes its sign. So right now, the point hk is -2, -3. Since h always changes its sign, we get x plus 2, not x minus 2. K doesn't change its sign. It will just stay -3. So our first step then is to substitute in our vertex points. Now what we want to do is use the other point that we're given, 0, 5, to find a. Because we need to find a. That's really what we're kind of looking for in this case. The vertex being given to us tells us what most of the equation already is. But without a, we're not done. So we have to find a. That's what we want to do. To find a, after we substitute in our -2 and -3, we use the other point. Now, of course, we know that this is x and y. So we're going to substitute in the point 0, 5 for x and y. That would be our next step, to substitute for x and y. So y in this case is 5, x in this case is 0, so inside that parentheses is 0 plus 2. And the minus 3 doesn't change. Now we need to solve for a. That's our last step. And once we've solved for a, we'll be done. Well, I have 5 equals, here, 2 squared is 4. So I have 4a minus 3. All right, 0 plus 2. 0 plus 2, let me erase this so it's a little bit clearer. 0 plus 2 is 2. So that gives us the number 2. Since it's squared, it's 2 squared. So it's a times 2 squared, which is 4a minus 3. Now we should be able to solve this equation pretty easily and get 8 equals 4a. So a equals 2. Since a equals 2, our actual function is y equals 2 times x plus 2 squared minus 3. So again, we have our different points. We have the vertex point, -2, -3, and we have a. We had to plug all those in. So we found a by substituting in all the numbers we had and solving the equation. Now let's look at an example using the intercept form. So looking at our graph over here on the side, I see I have a parabola. I'm given the point -2, -4. That's one point I'm given. I'm also given the x-intercepts of -3 and 2. Now, of course, we know that P and Q are both x-intercepts. So I'm going to just plug them in. And much like H, these values change their signs. So -3 becomes +3. 2 becomes -2. So again, I have substituted in. P and Q for my x-intercepts. Now, I've substituted in my other given point, which is -2, -4, as this point we were given. And we find a. We want to find a by first substituting in for x and y. Right, we want to substitute in for x and y. So we get x plus 3 becomes -2 plus 3. X minus 2 becomes -2 minus 2. And of course y is -4. So we go through and we solve this equation. Now when we solve this equation, -2 plus 3 is 1. -2 times -2 is -4. So we have -4a equals -4. That means a equals 1. Right? Again, this is a times 1 times -4. So -4a. So -4 equals -4a, which means a equals 1. That means that our quadratic formula, or our quadratic function rather, for this graph, this parabola that we're looking at, is y equals 1 times, and we don't need to write 1 times, x plus 3, x minus 2. So I didn't put the 1 in front. I didn't need to, because 1 times anything is itself. So I get y equals x plus 3 times x minus 2. That is the equation that will graph this parabola. All right, let's look at the checkpoint questions here just to get some more examples under our belt. Here we're told that we have x-intercepts -2 and -1. We're given x-intercepts, so we want to use intercept form. That's y equals a times x minus p times x minus q. Now, we have to plug in p and q x and y to solve for a. So let's plug in p, q, x, and y. Here's x, here's y, here's p, and here's q. So we're just going to plug in a whole bunch of numbers. That's going to be the first thing we want to do. So let's see, y is -4 equals a, which we don't know. X is -1 minus -2, so 1 plus 2. X is -1 minus q, and q is 1, so -1 minus 1. So we plugged in all our values. We're solving for a. That's what we're solving for. So let's go ahead and do that. Now, -1 plus 2, that's just 1. Right? That's we have a times 1 times -1 times -1 is -2. So we have a times 1 times -2. And that equals -4. So we work this out, we get -2a equals -4. Well, if -2a equals -4, then a equals 2. So if a equals 2, then our equation, the equation we're looking for is y equals 2, because of a, times x plus 2, because we changed the sign of p, times x minus 1, because we changed the sign of q. And that is our equation. All right, one last one. This time we're given the vertex, so that automatically tells us that we're going to be using vertex form. We want to use vertex form, that is y equals a times x minus h squared plus k. So that's the form we want to use. Here we have -h because we need to change the sign of h. We have k, and and we have x and y. So we're going to plug in h, k, x, and y. All right, y is 4, so 4 equals a, which we don't know. X is 0. K is 2, so minus 2. Remember, we changed the sign. Plus k, which is 1. So let's see. 0 minus 2 is -2. -2 squared is 4. So we have 4 equals 4a plus 1. We solve that equation just really quickly. We get 3 equals 4a, so we divide by 4. So a equals 3/4. Well, if a equals 3/4, then our equation is y equals 3/4 x minus 2, again because we changed the sign of h, squared plus 1. That is our equation. So we plug in everything we know. We pick a form first. Then we plug in everything we know. We solve for a. Then we stick a into the equation.